Hello again. We're going to begin the presentation on electrostatics. So you can open this up along with me if you like, or just watch this video with me narrating. Keep in mind, though, you have your term maps to look over and add info to as we talk about this topic. So this topic of electrostatics I mentioned last week, it's one of two topics within electricity. We're starting with electrostatics to get the fundamentals of electricity down before we start talking about electric circuits. For now, we need to talk about charge. So far in physics, we've just been dealing with mostly mechanics. That is the combination of mass, displacement, and time. So units of kilograms, meters, and seconds. Mix those three units together in all different ways. You get all the topics and measurements we've been studying, like force, energy, momentum, velocity, acceleration. These are all combinations of mass, um, displacement, and time. But now we're going to add a fourth fundamental property into the mix, and that is charge. The mathematical variable for charge is a lowercase q, or sometimes an uppercase q, but most of the time it's lowercase. And charge is yet another intrinsic property of matter, like mass is. The way we measure charge is within the unit of the coulomb. The coulomb is abbreviated with the capital C. It's named after scientist Charles Coulomb, kind of like how the Newton is named after Isaac Newton. So static electricity is just an operation that charges objects with this electric charge. Charge comes in two types, just arbitrary opposite words. We use positive and negative for our two charges, but those are, again, just arbitrary. I believe Ben Franklin coined those two opposite terms. So we have the positive charge coming from the subatomic particle of the protons. Negative charge comes from the subatomic particle of the electrons. There is a third subatomic particle of the neutron, and they contain no charge. They are neutral, hence their name. This should all be reviewed from chemistry, but there it is again. Now, the proton and the electron both have the same amount of charge, and that is known as the elementary charge. The amount of charge in the elementary charge is 1.6 times 10 to the negative 19 coulombs. That is an extremely small amount of charge, 10 to the negative 19. I mean, we're shifting the decimal place 19 times to the left here. So to have a charge of 1 coulomb is an extreme abundance of protons or electrons. Most of the time, we'll be dealing with charges that are significantly less than 1 coulomb. Another big idea to keep in mind is that since the proton and the electron have exactly this much charge, it is not possible to have charge that is not a whole number multiple of the elementary charge. For example, it's not possible to have, say, 1.8 times 10 to the negative 19 coulombs, because that would imply you could take the amount of charge from a subatomic particle and distribute just a part of it. It is not possible. It's got to be this amount, or twice this, or 3 times this, etc. This is just a chart showing us again, the charge as well as the mass and location of the 3 subatomic particles. AMU is the atomic mass unit. Protons and neutrons each have 1. And again, that's an extremely small amount of kilograms, 1.6 times 10 to the negative 27. The electron's even less massive than the proton or the neutron, about 1/187th of the mass of either of those. And that is 9.11 times 10 to the negative 31 kilograms, as you see on the screen. These numbers are also on your reference tables on the front page. This is just the end of the first video here. You can take a look at exit ticket number 1 if you've gotten this far. You can take care of that before we move on. See you in the next video.